Everyone. In this video, I'm going to walk through an example of how to set up an Excel template for interval estimates. So specifically, we're going to look at interval estimates or confidence intervals for a proportion. And I have an Excel file here that has the formula that we're going to be using. And I'm not going to go into the derivation of this in this video. We're just going to kind of implement this formula here. And the way I have my Excel spreadsheet set up is I have a space for the inputs to our calculation. And these are going to be specific to whatever question we're trying to answer. And then some calculations for the key pieces of our interval estimate, specifically the margin of error and the proportion. So I want to look at an example problem to use. I'm going to look at this example here. Suppose that a market research firm is hired to estimate the percent of adults living in a large city who have smartphones. So this is kind of the population that we're looking at, adults living in a large city. We're trying to estimate a percentage, which is a proportion, and the proportion of these adults who have smartphones. We're going to take a sample. It says 500 randomly selected adult residents are surveyed to see whether or not they have smartphones. And of those 500 people surveyed, 421 responded yes. So that's some sample information. From this, we can get our sample proportion. And the rest of the question says that using a 95% confidence level, compute a confidence interval estimate for the proportion of all adult residents in the city who have smartphones. So there's a few key pieces of information here that I want to pay attention to. The first would be the confidence level that we're using, 95% confidence. The second is what sample information we have. So in this case, I have the 500, which is the sample size, that would be my N, and 421, which is not the proportion on its own, but that is the number of yeses, the number of people in that group who said they had smartphones. So switching back to my spreadsheet here, I'm thinking about this calculation. Now, the interval estimate for a population proportion is going to be centered around our point estimate, which is the sample proportion. That would be p hat. I'm going to label this just P-H-A-T or P hat here. It's kind of hard to type the P with the little caret above it in Excel, but I just want some kind of label here. So I'm going to label a box P hat, and I'm going to use this to put in my sample proportion, and I'll put that in a minute. The other piece of information, or the other pieces of information I'm going to need here are, when I'm calculating the margin of error, I need to know what is Z star, that's my critical value, but the critical value depends on the confidence level. So I'm also going to put confidence level in here. And then I have my P hat, I already recorded that. I'm also going to need to know what N is. So I'm going to make a box for N. And I'm just kind of labeling what are the different inputs that would go into this problem. Now you can set this up in lots of ways. When we take our confidence level, in this case it was 95%, I'm going to put this in as a decimal. In order to calculate Z star, I'm thinking about what would be the Z value where area in the center is 95%. Often we'll look at some other pieces of information as we do that. So I'm actually going to move this up here. I'm going to move my confidence level up a little bit. You can do this in various different ways. There's not one right answer to set this at. But I'm going to take from my confidence level the area in both tails, which would be 1 minus the confidence level. If I have a 95% confidence level, that means I have 5% area in both tails. I'm thinking about a normal distribution here, chopping off the two ends. I'm trying to find this Z value here, and the area in the middle is supposed to be 95% or 0.95. So this also means the area in one tail would be that 5% divided by 2. So I'm going to do this number divided by 2. And then Z star is going to be calculated with the norm.inverse function. I'm going to take as my probability, this has to be the area to the left of the z-score that I want. Now I could either add the area in the middle with the area in this left-hand tail, or 0.95 plus 0.025, or I could do 1 minus the area to the right, or 1 minus the 0.025, or the area in one tail. Now I'm clicking on this number here so that if I do a new problem, all I have to change is the 0.95 and it'll automatically update all of these. So that's my probability. The mean and standard deviation I'm using are 0 and 1 because I want this to be from the standard normal distribution. Okay, so this is giving me my critical value. I'm actually going to change the formatting here. I'm going to color these differently. And again, this isn't something you have to do, but this is a clue to me that the confidence level is something that I'm going to enter. This is going to be different on different problems. But from that, I'm calculating the area in both tails, the area in one tail, and then my critical value. I'm also going to need to put in my p-hat and my n from the problem. So back to the example, the n, or the sample size, was 500. The p-hat is going to be 421 out of 500. So these are, again, specific to this particular problem. So I'm putting 500 in the spot that I labeled n. I'm putting equals 421 out of 500 in the spot labeled p-hat. So that's my sample proportion and my sample size. And then everything else is going to be calculated from that. So the margin of error E is based on this formula on the right here. It's Z star, which is my critical value. So I'm going to type in for my E equals Z star, clicking on that cell, times the square root, or SQRT, parentheses. And inside that square root, I want P hat, which again I have up here. So I'm going to click on the cell that I have labeled P hat, times parentheses 1 minus p hat. So I'm going to do 1 minus and then click on my p hat again. So mine is saying C10 times square root C5 times 1 minus C5. You're probably going to have different cell references if you have these things in different spots, and that's totally fine. You just want to refer to whatever values you have set up in your inputs area. Divided by, and then my n is here in this box here, so clicking on the cell that I have labeled n. And this is going to calculate my margin of error for me. And this is going to then give me my interval estimate, which is p hat minus e up to p hat plus e. So the lower bound here, I'm going to do another equal sign. I'm going to take my p hat value, clicking on that cell, minus my margin of error value, clicking on that cell. And then do the same thing for my upper bound, equals, clicking on my p hat cell, plus clicking on my margin of error cell. So this is calculating out my interval estimate. You could change the rounding on these if you'd like to. In this case, this is saying that between 81 and about 87% of all adults in that city have cell phones based on the sample information we had. But once you've built this template, in this case the template for proportions, if I do another interval estimate for proportions, the only thing I have to change is these input numbers, and then everything else will be automatically calculated for me. So if I go to another example, here's another example. A marketing research firm conducted a survey regarding the potential purchase of electric vehicles among adults aged 18 to 29. In a group of 50 adults, this is going to be my sample, or my n value would be 50, aged 18 to 29, 13 of them reported that they would consider the purchase of an electric vehicle. So that's my sample information. Find a 98% confidence interval for the proportion of all adults in this age group who would consider the purchase of an electric vehicle. So I'm taking, again, that sample information as well as my confidence level, and I'm going to come back to my template. I know my confidence level is 0.98 now, or 98%. This is going to recalculate my z-star, my critical value. My n is 50. I have a different sample size, and I'm going to put in my sample proportion, which was 13 out of 50. And again, I'm doing this as a calculation. If you have a fraction, you want to do equals and then 13 divided by 50. That'll give us the decimal value. So that means that the sample proportion was 26%. Here's my sample size, my confidence level. This is automatically calculating my critical value z-star, automatically calculating my margin of error e, and automatically calculating my interval estimate. So it's great to set these up once and then have it, do these calculations over and over for you. Now for the Tech Lab assignment, you're going to go into some of these other tabs, specifically the interval estimate for a mean, and do kind of the same thing. Look at what do we need to calculate in order to do an interval estimate for a mean? What inputs is that going to require? How do we get our critical value? All those questions, and have it set up to calculate your margin of errors. That's it for this video. Thanks.